This is part 20 in a series of videos in which I am reproducing the ADM-3A main board. If you're not familiar with the ADM-3A, then it's a dumb terminal. The design's getting on 45-50 years old, and it's used to interface old computer equipment. So it's basically what it suggests. It's just a dumb terminal. It consists of a screen, a keyboard, and electronics. There's no computer in there. It's used to control remote computer devices and that sort of thing. In this video, what I'm looking at is incorporating the reproduction board into a case. So in this project, I'm using the old case of a PET computer. I'm not suggesting you start tearing PET computers apart. This is just an empty case I happen to have lying around. There were some issues with it that I'll just briefly touch on in this video. The monitor didn't work, so that was repaired, and as you can see, I've stripped it right down. I've given it a really good clean. I've had to deal with some issues on the paintwork, but that's looking quite good now. The main issue I had with it was the top cover was broken. This is plastic, it's plastic moulding, but one of the lugs was broken in half and the other one was snapped off almost completely. So what I decided to do, rather than try to repair these lugs, is to remove them completely. So as you can see, I've filed them down so they're flush with the rest of the moulding. And then what I did is to lower the monitor chassis, if you like. So normally this would be higher, and normally there's a gap between the bottom of the display surround and the main case, usually about 20 millimeters or so, and that's what the lugs fit into to hold the rear panel onto the back of this base plate. So what I've done is I took this completely apart, drilled out the rivets that or the spot welds that hold these uprights to the base plate, took the amount off the bottom of each of these side sheets that I wanted to lower it by, and then riveted this back in place, making sure it was properly aligned, because obviously the alignment of this is important, or it won't match the slope of the outer cover. I then shortened all these spaces holding the PCB in by the same amount, and then what I did is made up some spacers. So I need to be able to screw the back cover in, of course, and there are holes in here, but of course I don't want to put a long screw in like this because the cover's plastic, and if you have a space like this between the back plastic cover and where you're screwing it into, it will just crack the cover when you try and tighten it. So I've made up these spacers that screw to the rear of the base plate. I had to notch out the front and back of the base plate. This would normally go across at this level, but of course the PCB overhangs, so this has to be cut out. Similar at the front, because the tube is now lower into this base, I had to cut out the tube profile from the front flange as well. And now the rear cover, or top cover, should slide on. And as you can see, it fits on there quite nicely, and the whole thing looks quite neat and tidy, and I actually prefer this look to the original. It's much lower and sleeker than the original, and it makes the entire finished unit much smaller. So I've checked this and it does still work. I'll just get this off the bench and we'll look at the next part of the process. So the next step in the process is to get the board fitted into the lower part of the PET chassis. So what I've done is taken out the mains transformer. I've taken this out. I was going to reuse this originally, but I've decided not to. It wasn't really practical to try and use that. So of course what we have to try and fit in here is the PCB. So I've got a bare PCB here, and as you can see, it is a very tight fit in here. In fact, I'm going to have to relocate the prop at some point, but the idea is to fit this slightly off to one side, and then of course we have the mains transformer. Now I could have tried mounting this on edge here, and it probably would have worked fine, but I don't really like that arrangement. It's not particularly secure. And also, of course, I still need some arrangement for the main socket. So what I've done instead is make up this bracket. So it's made out of the same gauge steel as the chassis, and I've made it so it fits nice and snugly into the chassis itself. So I'll just pull this board forward, and this is a mount for the transformer. So I've made it so it's plenty strong enough to hold the weight of the transformer. It's actually made of one piece and bent, and where the flanges meet I've brazed it so it's a very rigid assembly, and as you can see I've painted it so it looks the same as the chassis. And then that just fits in this corner, and there are holes that I can screw it on using the original bolt holes in the rear of the chassis, and then I will use pop rivets for the other 3 mounting holes. So that fits in that corner, it's slightly higher than that, and then the transformer sits on top. And as you can see, that leaves plenty of space underneath for the board. I have tried the real board and there's plenty of space, so it should all fit in there fairly well. And this is now also the mount, of course, for the mains socket. I've also decided to put a mains switch at the front of the chassis, so it'll be in this front corner. I don't really like it around the back of the unit, it's a bit inconvenient, and as I was doing this I thought I'd take the opportunity to move the mains switch to the front. Okay, so this also means I can assemble all the mains components before I fit this into the unit. So I can bolt the transformer to the top. This holds for a grommet, and it allows the mains cables from the transformer to pass down to the socket underneath, and then the main socket itself can be fitted, and that just passes through the aperture on the back of the chassis before this is fixed into place. And the flanges are just to give this more strength and makes it rigid. So what I'll do now is get this assembled, and then we'll have a quick look at it, and we can then fit it into the chassis and decide exactly how the board's going to be mounted in there, and also I'll deal with the prop. Okay, so that's assembled. Transformer on the top. We've got the main socket on the back. I just need to get it wired up. I'll do that once it's in the chassis. And this assembly can now be bolted into the chassis. So I'll just grab the chassis, get it on the bench. So this just fits into the rear corner. So that fits in like that. There are holes on the side I can use to rivet it in place, and then the 2 original screws, one of which will be used for the earth lead. This then plugs into the corner of the main board, and this of course goes up to power the monitor. I've arranged all this so there's about an inch between the top of the transformer and the underside of the top cover. Before I bolt this in place, of course, I need to drill the holes for mounting the main board, make sure all that lines up, and also cut an aperture on the front for the new main switch. And I'll be rotating this by 90 degrees so that it actually goes down this side. I'm going to try it first in its current location just to see if the board will fit underneath it, but I suspect it won't, so almost certainly this will have to go down this side. Doesn't really matter which way it goes, it's just one extra thing that needs to be jiggled around just to make this setup work. We're getting close now. Once I've got the main board bolted into the chassis, get the transformer wired up, refit the top cover, then that will just leave the keyboard to sort out. Okay, so that's the first fit. It seems to go in there okay. What I've done is made some nylon standoffs. There are 9 threaded bushings underneath the PCB, and I've drilled the base of the PET chassis to suit the holes in the ADM PCB. So it's unscrewed in place, nice and firm. Unfortunately, the PET chassis is about 2mm too short, so what I've had to do is slope the ADM board very slightly. The front of the PET chassis slopes outwards the higher it goes, so by raising the front edge of the ADM PCB it just about fits in. I've also moved the main switch for the power to the front. It's far more convenient than it being at the back, and obviously this connector goes to the ADM board, that's the main power, and these wires will go to power the monitor once that's fitted. I've already put an inline connector on here. It's only just resting in here at the moment. The screws are all loose, so I will tighten up the screws once it's been tested. And then on the back, also we just have the main socket, and there's internal fuse underneath this bracket, but obviously the switch is now at the front. And then we just have the two D-type connectors. So it's fitted in there quite neatly. It looks a lot better than I'd expected. And what I'll do now is get the top part of the PET chassis bolted back into place, and we'll see how it all looks. The other thing I need to do, of course, is make up a lead to connect the ADM board to the monitor, and that's just really putting the right connector on the end of this cable. So once that's done, it's all ready to have the keyboard sorted out. So as I say, I'll get this bolted together and then we'll give it a quick run, see how it looks. Okay, so that's how the inside of the case looks. I will be tidying this up, of course. There'll be just one of these cables, so this will run straight up to the monitor, and this will be much shorter. It will connect directly to this cable, so the internal cabling will be very neat and tidy, and I'll just find some way to permanently attach the speaker. Other than that, it's looking quite promising. We'll have a quick look at the back, and you can see how the back of the machine looks. Okay, so that's the rear of the unit. As you can see, it's nice and neat and tidy. D-type connectors are easily accessible, and because I put mounting pillars close to them, they're nice and rigid, so they're not going to move around everywhere. Socket on the back, switch is now on the front, of course, and these are the two extra screw holes that I drilled to mount the top cover. As I mentioned, the tabs that normally hold it in place were broken off, and rather than try to repair it, I decided to lower the entire monitor. Makes it much neater anyway, and does actually look far more like the original ADM with the monitor lowered like this. So what I'll do now is spin it round and we'll power it up and see if it actually works. Okay, we'll try and turn it on and see what happens. So we're getting the cursor showing, so that's the prompting sign. No keyboard fitted yet, of course. This is not grounded, by the way, so we'll see a bit of bouncing of the display. I haven't got the ground straps wired together. It does tend to do this because of the nature of the display on this. What I should be able to do now is simulate some key presses, so I'll short together some of the keyboard connector pins and see what happens. And so you can see it better, I'll move the camera closer to the display and just try simulating a few key presses. I've now got the shift key shorted out, so should get uppercase characters, and of course the beeper is still working. Let's try one more. Okay, so appears to be working. I'll just move the camera back and we can have a quick look at the unit from a bit of a better angle. Okay, so as you can see, the project is certainly coming along, and all I have to do now is put together a keyboard and then tidy up the internal wiring, and then we can do some final testing. As ever, the flickering is just due to the camera, it's not evident in real life. It's a very nice flicker-free display. So in the next video I'll look at a solution for the keyboard and decide how I'm going to address that, and then we should be getting fairly close to the end of this project. As ever, comments are welcome, and I will be putting the boards on my website probably within the next day or so.